In this lesson, we're going to learn about variables in Python. And a variable is used to store value in it, and it's created when you assign an equal sign followed by a data type. The rules for variables is that it must start with a letter or underscore. It can't start with a number, and they are case sensitive. So let's create a variable called x and set that to a number. Let's run this and let's call out our variable. And you see we get the 122 that we assigned to our variable. We can also assign strings to our variable. This is a string. Let's run this. Let's run this cell. And you see we get what we stored in our variable. We can also make multiple variables on one line. So after x, y, z. Then we're going to put a value. Let's put a decimal number, or it's called a float. Let's just put another number. So let's call it our, first we need to run this cell and press shift and enter to run it. Let's call out y. And it's assigned in the second place, and we could also assign z. We can also add, multiply, and divide variables. So let's set x to 20, y to 10, and let's run this. And let's do x plus y and run that cell. And you see we could perform addition, subtraction, multiplication to our variables as long as it's an integer or a float. We can also concatenate strings. So let's write this is a message. This is another message. And let's run this cell. And now we concatenate two strings by the addition sign. And let's run this cell. And you see we concatenated our variables. If we want a little space here, we could simply add a colon with empty space. Some space in between there. And add. Now let's run this. And we got the space that we wanted. We can also override variables. So now x is this string right here. Let me call it. And now we could reassign x to something else. So let's assign it to a number. Let's run this and let's call out x. And you see we get what we assigned to our variable. So this is variables in a nutshell. And I'm going to go over data types. And as we've seen in the previous video, variables can store different data types, and a data type represents what type of data it is and what operations can be performed. We will go over the first three data types that we see here, and the rest of them I will explain it in separate videos. So an integer is basically a number. So let's set a variable to an integer, 23. Let's run this. And if we want to see the data type of this variable, we use a function called type. And in between brackets, we put our variable. So let's run this. And you see we get an integer. Now let's do a float, and a float is simply a decimal. So let me set b to 3.33. And let's call out our variable. Actually, let's call out the type. So we can see the data type. And you see we get float. And a string is anything between single or double quotes. So let's type a string, and a string will say hope all is well. Let's run that. And let's call our variable. Let's call the type of our variable so we can see that it's a string. And you see we get a string. We can perform arithmetic operators on integers and floats. So let's say I want to do a plus b. We will get the answer to that because we stored 23 in a and 3.33 in b. But if I wanted to add C, we'll get a mistake because we can't add integers and strings or floats in a string. We can only add integers and integers or floats and floats. We will go over the list data type in the next video. And we're going to talk about list. And a list is a collection of different data types like integers, floats, strings, as well as objects. A list is used to store multiple items in a variable, and it's created in between block brackets. So let's create a list. Let's set a variable equal to our list. So I'm going to say 234, 3.3. I'm adding different data types into my list. And hey, what's up? Let's run this. Let's call out our variable. And you see we get our list. Now let's check the type of this variable. It gives us the data type of a list. A list allows duplicated values in it. So let's create another list. 1, 3, 3, 4.4, 5.5. Let's call out our variable. And you see we still get our list. Let's see the type. And you see it's a list. A list is mutable. And that simply means that a list items can be changed after creating the list. So to enter a new value at the end of the list, we use the append function. So now let's add a value at the end of this list. So b.append, and in between the brackets, we put what we want to append. Let me just put 999. And then let's call out our variable. And you see 999 was added to the end of our list. We can insert a new value at a given index of a list. So let's say I want to insert 7 in our first index. And index is counted by starting with 0. So 0, 1. And I want to put the number 7 in here. So I would write b.insert. And we say we want it at the first index, so 0, 1. So we put our 1 as the first argument. And then we wanted to put 7. And now let's call out our variable. And you see we insert 7 in the first index. If we want it in this one, we would have to put 0 because indexing starts with 0. Let's just do another example and insert a string. So b.insert. And I want to put a string on the 0, 1, 2 in the second index. So 2, and the string is hi. Let's call out our variable. And you see we put hi in the second index. To remove a value from a list, we use the remove function. So we're going to put b.remove, and in between brackets, we put what we want to remove, and let's remove the 999. Let's run this, and you see the 999 was removed. If we want to call a range of items in our list, we can use indexing. So we'll type b, and in between block brackets, let's say we want from 7 to 0, 1. So from the first index to 0, 1, 2, 3, 4 to the fourth index. So 1, 4. But indexing is inclusive. So we need to go 1 more higher. So we'll put 5. And let's run this. And you see we get from index 1 to 5. We can also just get the high by putting the index number. So 0, 1, 2. And let's put 2 here. And we should get high. If we want to get from high all the way down, 0, 1, 2, so we leave the 2 here, and we just put the semicolon and don't put anything after that. So let's run this cell, and you see we get from the second index to the rest of our list. We're going to talk about tuples. And a tuple is used to store multiple items in a variable, and these items could be different data types like integers, floats, and strings. And a tuple is just like a list, except in tuples we use brackets, and tuples is immutable, which means that it cannot be changed after creating the tuple. So let's see the type of our variable that we named v. Let's run this, and you see we get a tuple. And also notice that a tuple also allows duplicate values. We can also index in tuple. So let's say if I want to get the hello, 0, 1, 2, it's in the second index. So let's run this cell, and you see we get the hello. And like I said, tuple is immutable, so we can't make any changes to it. So let's try with the remove function. And let's say we want to move 2. We will get an error. Let me show you something new. Negative indexing. So let's say if I want to get the last item in our tuple. And let me show you how to do that. And let's put -1, and we should get 2. If we wanted to get world, we would do -1, 2. So -2. And let's run this, and you see we get world. Let me remove this. If we want to get everything from the starting to the world, so we would say 0, 1, 2, 3. And we would open our colon and put 3 on the right side of the colon. And let's run this, and we see get everything from the beginning to world. But remember we said world, and indexing is exclusive, so we'll go one more up, and you see we get world. So that's tuples. In this video we're gonna speak about sets, and a set is a collection of different data types, and the set data type arranges items in ascending order and is created within curly brackets. We can add or remove an element in a set, and the set does not allow duplicated values. So here we have a list of our set, and we put duplicated values, and we see that we put it in curly braces. So let's run this cell, and you see it removed the duplicated values. Let's see the type of this variable, and it should say set, and here you see that the data type is a set. Let's do an example with some strings. And let's call out our variable, and we see it removed the duplicates, and it also put it in ascending order. So here it's in ascending order numerically. Here it's in alphabetical order. We can add or delete elements to a set. So let's say we want to add an element to here. So we just put s.add, and in brackets we put what we want to add. Let's add a number. And let's run this, and let's call out our variable. And you see it puts the numbers in front of all the strings. Let's add a string. Hello. And then let's call our variable. And you see it added a hello. To remove, we use the remove function in between here, and we put what we want to remove. And let's remove this. Let's call out our variable. And you see that this string was removed from our set. So this is a quick tutorial about the data type set. And we're gonna go over dictionary. And a dictionary is a data type that is a combination of keys and value pairs. The keys and value pairs are separated by colon, and the dictionary is created within curly braces. So here I created a dictionary, and let's see the type of our variable, and we see that it's a dictionary. The keys can be integers, strings, floats, and also our values can be integers, strings, and floats. So let's create a dictionary with string keys. So let's set state to, and we're gonna give states to our keys. So we're gonna say New York, and I'm gonna just give that a random value. Wisconsin, and Florida. Let's call it out, and you see we have our strings as keys and integers as values. Let me put a string in the value for Florida's. I'm gonna put very hot. And you see we can have string keys and string values. So a dictionary doesn't allow duplicated keys, but we can enter duplicated values. So let me just take this example here. Control C to copy, Control V to paste, and I'm gonna add duplicated key. Let's call out our variable. And you see our keys with Don was removed. But let's give this duplicated values. Let's remove this and give 3 Don. Let's run this, and you see it allows for duplicated values. A dictionary is mutable, and simply what that means is we can add, remove, or change items in a dictionary. So let's call in our D variable. So let's add an item to our dictionary. So to do that, we write D, block brackets, we set our key, and we set that equals to whatever value we want. So I'm gonna say Sean. Let's call out our dictionary, and you see Sean was added. If we want to see the keys of our dictionary, we simply use the keys function. And let's run that, and you see the keys. The same if we want to see the values, we call our values. Let's run that, and we get the values. Let's say we want to delete the key along with its value. So let's say we want to delete this pair. We use the pop method, and in between brackets, we put the key. Let's call out our variable and run this cell. And you see our item associated with the key 1 was deleted. So this is a quick overview of dictionaries in Python. And we're going to talk about strings. And a string is made up of 1 or more characters, and it's surrounded by either single or double quote. So let's write, this is a string. And let's see the type of this, and we should get string. Let's run this, and here you have it. Let me put a string in a variable. So let's say we have a word like I'm or don't. Let's call out the variable. See, and we get an error. We need to surround this by double quotes. If we have words like don't and I am and so on. So let's run this, and you see we printed our string. We can use the print function to print strings. So let's print S, and you see it does the same thing. To access an element in our string, we can use indexing. So let me create another string. This is another string. Let's say we wanted to access 0, 1, 2, 3. We want to access this S. We'll simply call out our variable, and in between block brackets, we put in the index number. And let's run this, and you see we get the S. If we want the I, we put in 2, and so on. We can get a range of characters in our string. So let's say we only want this is. Let's say we'll start from the 0 index. And we're gonna end in 0, 1, 2, 3, 4, 5, 6. Let's put 6. Indexing is exclusive, so we have to go one more higher to get that S. And let's run this, and you see we get what we asked for. There's other functions in a string. The length method brings in the length of the string. So let's put in our variable where we stored our string, and there's 22 indexes. The strip function removes white space of a string. So let me bring this here. And white spaces is just blank spaces before or after our characters. So let's call st.strip. Let's run that. And you see it removed the blank spaces. Let me take this here, bring it back. Let's say we want to capitalize the characters in our string. We write upper, use the upper function, and let's run this. And you see we capitalized the values in our string. Let me create another variable. Into lowercase our string, we use the lower function. And let's run that. And you see all the letters has been lowered. Let's call our variable low. And let's replace this with another value. We use the replace function. So let's call our low variable, and you call out our replace, and in between bracket, we want to replace this, and in the second argument, we put what we want to replace it with. And let's replace it with that. And let's run that. And you see this was replaced with that. There's other functions we can do with strings. If you want to know more, just let me know in the comment, or there's documentations online for it. Welcome to another video in the Python video playlist. And we're going to talk about data type casting. And what this means is converting one data type to another. So let's change an integer to a float. So first, let's set a variable to an integer, and let's look at the type. And let's run that, and you see it's an integer. So to change that into a float, we use our float function, and we put x. Let's set it equal to our x variable. And now let's check the type of our variable. And let's run this. And you see we changed it to a float. Now let's change an integer to a string. So let's set x to an integer. We'll see the type of x, and you see it's an integer. So to change it to a string, we use the str function and put our variable. Let's reassign it to our variable and call out our variable. Well, and we said a string is anything between single or double quotes. Let's check the type. And you see we get a string. Now let's change a float to an integer. Let's set y to 12 point to a decimal. Let's check the type, and it will give us a float. And to change it to an integer, we use the integer function. Let's put in our y, and let's assign it to our variable, call our y, and it's an integer. Let's see the type. And you see we change our float to an integer. Now let's do a float to a string. Set y equals to, let's see the type of y. You see it's a float. To change it to a string, we call our str function. Let's put in our y. Let's reassign it to our y. Now let's get the type. Let's run that, and you see we change it to a string. Now let's change a float to an integer. And we can only convert number strings to integers. So let's set w to a number string. See the type of our variable, and it's a string. So now let's change that to an integer. Let's reassign our variable and call our w, or let's see the type. It will be an integer. And here you have it, it's an integer. So this is data type casting. And the range function creates a sequential list of numbers that start from 0 by default and ends at one value less than a specified number. Another thing about range is that we need to put it in a list because the range by itself creates a range object. Let me show you what that means. So let's set x equals to range. Let's say we want 0 to 9. See, it only gives us an object. So we have to put this range in a list so we can get our list of values. Let's run this cell again. And you see we get a list starting from the 0 index to 10. Actually to 9. If we wanted 10, we would have to put 11 here. We can indicate where we want our values to start from. So let me just copy this. And let's say I want to range from 1 to 20. So I'll start with 1 and then end in 21. And now let's run this cell. And you see we get a list from 1 to 20. Let's start it from a different value. Say 7. Let's run this. And we get a range from 7 to 20. We can have a third argument that determines the interval. So let me just copy this, paste it here. I want to start from 1 to 20. And let's run this. And let's say we wanted to go by 2s. The third argument is we will give it an interval sequence of 2. So let's run this. And you see our list by 2s. We could add another value here, so it can be by 5, and so on. Let's create a list from 0 to 90, and we want to give it intervals by 10. So we want from 0 to, let's do 100. And we want to count it by tens. So let's run that. And you see we get our list from 0 to 100, 0 to 90, and it's intervals of 10. If we want 100, we could put 110 here. And let's run that. And you see we get from 0 to 100 in intervals of 10. So this is ranging in Python. Now let's move on to indexing. And indexing is an inbuilt function in Python that finds the given element in a list, then returns the position, and indexing starts in 0. So we created our list here, and we put our variable in dot notation, and then we call out our index. And we want to find the index value of this 56 here. So it should be 4 because indexing starts with 0. So we'll start 0, 1, 2, 3, 4. So it should be the 4th index. Let's say if we want to get the 0 index and we see this 12 is in the 0 index. So let's call it here, and you see we get 0. If there are any duplicated elements in the index returns the first one. So let me copy this, paste it here. Let's add a duplicated element, 12. And let's run this. You see we get the first position when there's duplicated values in the list. To check what element value is present, we use the blocks. So let's say we want a 0, 1. We want the first index, which is 23. In block brackets, we put the index value of 1. And let's run that. And you see we get 23. 0, 1, 2, 3. If we want 45, we put 3. To get a portion of our list, we use a range of indexes, and we surround it by block brackets, and it's separated by colon. And the first value is the start index, stop index, and we can have a third argument for the step index. So let me just copy this, paste it here. And let's say I want the index from 0, 1, 2 to 3, 4, 5. So I'll put the index 2, colon, 5. So 0, 1, 2, it should start from 34 and ends at the 5th element. Let's run that. If we wanted the 56, we would need to go one more. And here you got our range of values in a list. Let's say we want to start from the beginning to the 0, 1, 2, 3 to the 3rd index. We would write X, and we would leave our starting index blank to start from the beginning to the 0, 1, 2, 3, 4. Let's do 4. So from the beginning to the 4th index, and let's run that. And you see we left this blank, so it starts from the beginning and it ends at the 4th index. If we want to start from the 4th index and get the remaining items, we leave this side blank, and we want to start from the 4th index. So from 0, 1, 2, 3, 4, and the rest of our items will be printed out. So let's run this. And you see 0, 1, 2, 3, 4 from the 4th index to the end of our list. So let's say if I want to start from 0, 1, 2, 3, 4 to the 4th index, I'm gonna leave the start index blank. 0, 1, 2, 3, 4. Let's just do 5. 5. And then we're gonna put a step of 2. So it's gonna skip every other index. So let's run this. And you see 0, 1, 2, 3, 4, 5. And it's counting every second value in the list. So it's skipping 23, going to 34, skipping 45, going to 12, and so on. Now let's move on to negative indexing. Before we do this, let's copy here, paste it here, add a couple more cells. And let's say we wanted this last value here. We can do negative indexing. We put -1 here, and it will start from the end of our list. And you see we get 78. If we wanted 67, 2, 56, 3, and so on. So let's 0, 1, 2, 3, 4. Let's show index elements from the fourth index going downwards, and we're going to give it a negative step value. So we said we want it from the fourth index down, and we're going to give it a negative step value. Let's run this, and you see it goes from 12 with a negative step value of 1 to a negative step value of 2. And you see from our fourth index, 0, 1, 2, 3, 4, it's skipping each one and going to the second value. So this is indexing in Python in a nutshell. Now let's move on to operators in Python, and the operators we're going to go over is arithmetic, assignment, comparison, and logical. So in arithmetic operators, we have the addition, subtraction, multiplication, division, exponent, floor division, and modulus. I will go over floor division and modulus when we get there. So the addition we've been doing in previous videos, 5 plus 5, 5 minus 5, 5 times 5, 5 divided by 5. And let's do the exponent. So 5 to the 5th power, and we get this value. Now let's do the floor division, and what that does, it gives us the answer without a decimal. So let me do 12.5 divided by 5, and you see we get 2.5, and with the floor division, it rounds it to a whole number. And then the modulus returns the remainder when we divide. So the modulus is the percent sign. Now let's run this. And if we divide 12.5 by 5, we will get 2 with a remainder of 2.5. Now let's move on to assignment operators. And assignment operators is used to assign values to variable. We have already been using the equal sign. And then we have the add and equals, minus and equals, multiplication and equals, and division and equals. So let's set x equals to 5. And then I want to add and assign 4. And then let's call out our x. And you see we get 9. So this is the same as saying x equals x plus 4. It's the exact same thing, but a shorter way to write it. So we can do the same with minus and assign 4. We get 1. Multiply and assign, get 20. And divide and assign, we get 1.25. So this is assignment operators. Now let's move on to comparison operators. And it is used to compare two values. And we'll get true or false. So let's set x equals to 20, y equals to 15. Let's run that. And this is the equals operator, the not equal to, greater than and less than, greater than or equal to, and less than or equal to. So let's see if x is equal to y, and we'll get a false. Let's see if it's not equal to y, and we'll get true. Let's see if it's greater than y, we'll get true. Let's see if x is less than y, we'll get false. Let's see if it's less than or equal to, we should get false. And greater than or equal to. And this, and we get true. So this is comparison operators. Now let's move on to logical operators. And logical operators, we use the keyword and or not, where and it returns true if both statements are true, or returns true if one statement is true, and the not reverses the result. So let's set variable b to 20. Let's run this. And we want to see if b is less than 4 and b is greater than or equals to 25. And we should get false, because with and, both statements separated with and needs to be true in order to get a true output when using the and operator. When using the or operator, it returns if only one statement is true. So let's make one statement true. So we made it true because we said b is less than 40 and b is greater than or equals to 15. So let's only make one statement true and use our or operator. And it should come back true because at least this statement is true. B is greater than or less than 15. And let's run this. And it's true because one of them is true. Both of them needs to be false for us to get a false output. So let me just put b equals 15 here. Double equal signs. Let's see, we get false. Now let's use the not. And the not is used similarly to a function. So not, and in between brackets we put our statement. So it's gonna reverse anything. So let's say we said b is equals to 2. And let's run this. And it's gonna say true. But we know b is not equals to 2. So that's logical operators. Now let's move on to for loops. And the for loops is used to iterate over a sequence of items like lists, tuples, sets, strings, even dictionaries. It can execute a block of code a number of times. And here we have the syntax. In our for loop objects, we write the for keyword and we declare a variable. We use the in keyword and we write the sequence that we want to use in our for object. And then we have to put a colon, indent, and write the body of a loop. So let me create a list. Now let's create a for loop. So I'm going to say for I, and I is our variable, in X, which is our list. Let's put a colon and press enter. And it already created the index for us. So we wanted to print, loop through our list and print it. Let's run that cell. And you see we loop through our list. We can also put our list in our for loop object like so. Let me just do it quickly. Cut this and paste it here. Now let's run this cell, and you see we can do it by putting our list in the for loop object. We can also use for loops on tuples and sets. So let me create a tuple called cities, and I'm going to put some cities. Now let's create our for loop object. So for X in cities, I want to print X. Let's do another example and let's multiply each element of a list by 10 using the for loop. So let me create this list. 1, 2, 3, 4, 5, 6. And then we want to create our for loop object. So for X in Li, we're going to multiply and assign our variable to 10 because we want to multiply each element in the list by 10. This multiply and the sign is the same as saying X equals X plus 10 or times 10. So now let's print X. Move this here. Let's run that. And you see we multiplied every element in our list by 10. Let's do another example. And let's also print a string a certain number of times. So let's set a variable equals to, and we're gonna create a range. And we want to range from 0 to 4, meaning I'm gonna print a message out 4 times. So let's create our for loop object for x in our list. Let's print just our message. And let's run that. And you see we printed our message 4 times. If we want, we could print it 10 times, 8 times, whatever we like. So this is for loops. Now let's move on to the if and else statement. So we use the if statement to run a code if a certain condition is true. If the condition is not true, then the else statement is executed. And here we have the syntax to create our if-else object. We write if, and then the condition, colon, and then we indent, and then we write whatever code we want to be executed. If the condition is not true, then the else statement will be executed. So let's set a value to 30 and create a if-else statement. So if the value is more than 20, we want to print value is greater than 20. And let's run that. And it's going to print that since our condition is true. And if our condition is not true, we write the else, colon, and then we want to print the value is not greater than 20. So now let's make the value less than 20. Let's run that. And you see our else statement is printed. The if-else statement could be written on a single line. So let's go ahead and do that. And it starts out with the print. So we're gonna print x is more than y. And then it takes the condition. So if x is greater than y, and then next it takes our else statement, and then we print x is less than y. And let's run this, and you see it prints x is less than y. So this is how you do the if-else statements in one single line. Now let's move on to the elif statement. And I'm gonna show you about the elif statement by creating something where that outputs whether you can drink or not based on your age. So let's set age to 22. And I want to say if age is greater than or equals to 21, I want to print you are old enough to buy alcohol. And then I'm going to put the elif keyword. Elif age is greater than or equals to 18. We want to print old enough to join the military, but not old enough to buy alcohol. And we can use as many elif statements as we want. So I'm going to create another one. Elif age is less than 0. We want to print, print invalid age. And then we need to put our else statement. And what we're going to put in our else statement, then we need to put in our else. And the else statement will execute a code if none of these conditions are true. So we're going to put else print you are too young to drink. So let's run that with age 22. Let's see what we get. You're old, we see we get you're old enough to buy alcohol. Let's see if you're 19. You're old enough to join the military, but not old enough to buy alcohol. Let's put an odd number like -12. We get invalid age. And let's put someone younger than 18. And let's run that. And you see you get you're too young to drink. So that's the if, elif, and else statement. Now let's move on to while loop. And a while loop repeats a block of code as long as a certain condition is true. For while loop, we use a variable for increment purposes. And this is necessary because the loop will run forever. So let's create a while loop, and first we have to initialize a variable. So we're gonna set x equal to 0. Then let's give our condition. We type our while keyword and give our condition x is less than 5. We put semicolon. We press enter and it indented automatically for us. What we want to do, we want to print x and then we increment the variable. So x plus equals to 1. This is the same as x equals x plus 1. So now let's run that. And you see we executed our for loop. So basically what this is doing is checking to see if x is less than 5 and x is 0. So it's going to execute our code. So x is less than 5, so we're going to print x, and here we have 0. And then we're going to increment x by 1. So x is now 1, and it's going here. So x is less than 5, so it's going to print x, which is 1, and then it's going to increment. So now x is 2. 2 is still less than 5, so we're going to print 2 and increment the 2 by 1. Now it's 3, 4, and so on. And when it gets to 5, it's going to stop because the condition is not true. Let me copy this. Let me just paste it here. And let's see what happens if we give the increment before the command. So let's cut this and let's run that. And in the while statement, it's going to execute this line of code first. So x is 0. So while x is 0 is less than 5, we're going to increment. So now x is 1, and then we're going to print x. That's why it started out with 1, because we put the increment code as the first thing that's going to happen in our while loops. Let me do another example. Let's print a message 5 times. So let's set let's initiate a variable. And we want to say while a is less than 5. We want to print our message. And then we have to increment because the loop will not stop. So a plus equals to 1. Let's run that. And you see we printed our message 5 times. Let's do one more example where the string tells us the value of the a after the increment. So let's set a equals to 0, while a is less than 7. I'm gonna print, I'm gonna use the f string, let's say the value of a, and in curly braces we put our variable, and then we increment a plus equals to 1. And let's run that, and you see we created our loop. Like I said, a is 0, so it's going to print the string while a is 0, and then it's going to increment to 1, and then it's going to check if 1 is less than 7. It is, and then it's going to print the next line of code. Then it increments by 1. So 2 is less than 7. It is. It's going to execute the code and it increments. And now a is 3, 4, 5, 6, and so on. And it's going to go until the condition is not true. So that's while loops. Now let's move on to functions. And we're already familiar with user-defined functions like print and type, length, and so on. But we can also create our own function. And to create a function, we use the define keyword, and the function can be defined with 0, 1, or more arguments. So let's define a function with 0 arguments. So define function, and let's create a name of our function. So I'm gonna call it our func. And then what we want this function to do is print our first function with no arguments. Let's press shift and enter, and nothing happens because what we need to do next is call our function. So let's call our function, or our func, and let's run that. And you see our function was executed. Now let's define a function with one argument. So I'm gonna call my function uf, and we're gonna put an argument a. And what we want to do is print a. Let's run that. So now I could call in my function and put whatever I want in for a. And let's run that. And you see something. We can put integers, anything we want in for a. Let's run that and we get 44. So now let's create a function with 3 arguments. And we're gonna do this by creating a function that adds 3 numbers. So create function called add, and we're gonna put in our variables w, x, y, colon, and we're gonna create a variable called z, and what we want it to do is add the arguments we put in our function. Next we need to return z, and let's press shift and enter. So now let's call our function we just created called add, and let's plug in some numbers. So I'm gonna put 10, 20, 30, and let's run that. And you see the function adds these numbers. Let's do one last example, and let's create a function that lets you put your first name in front of a given last. So call our function fname, put our variable x. What we want to do is print x plus, and the last name I'm going to give it is code. So let's run that. Let's call in our function, and we could put whatever name we want. I'm going to put done. And you see we get done code. We can add a space by just putting space after the n, or we can add the space right here. Let's run this cell, and we get the same thing. Now let's move on to Lambda. And Lambda function is used to create single line functions. It's an easier way to create user-defined functions since it's in one line. So now let's create a Lambda function that multiplies 2 numbers. So in Lambda function, first we have to create the variable, call our keyword Lambda. Let's put our arguments x, y, and what we want it to do. We want to multiply both of the numbers. Let's run that. Oh, it's not a capital L. Lambda. Now let's run that. And let's call our mult. And in brackets, we put the values we want to multiply. So 2 and 5, and we get 10. Let's create another Lambda function that squares the value. So set the variable sqr, and we're going to use 1 argument. In the above example, we use 2 arguments, and then we want to square the value. Let's run that, and let's write. So say we want to square number 3, and you see it squares our value. Let's do one more example, and let's create a Lambda function that concatenates 2 given strings. So let's create x equals hi, y equals hope you having a great day. And now let's create our Lambda, Lambda. We make our arguments a and b, and what we want to do is print x plus y. Actually, we need to add space, so let's add an empty string with space, and then we add y. Let's run that, and now let's concatenate the strings. So msg x, y. And let's run this. And you see we concatenated our strings. So this is Lambda function. So now let's move on to the break statement. And the break statement can stop a loop even if the condition is true. And we use it in for loops and while loops. So let's create a for loop. Cities. So let's create our for loop for x in cities. We want to print x. Let's run this. And let's say we want the loop to stop at Castries. So New York won't show. So what do we write? We write if x equals Castries, put a colon, then we're gonna write our break statement. And let's run that. And you see it loop through our cities and it stopped at Castries. If we put the print after the break, press Ctrl X to cut, Ctrl V to paste. Let's run that. It's gonna remove Castries because it's executing our first line of code before the print. So if x equals Castries, it's gonna break and then we're gonna print. So it won't include Castries. Let's do another example. Let's create a list. So I want a list and a range from 1 to 10. So this is the same as saying li equals 1, 2, 3, 4, all the way to 10. So now let's create our for loop. So for I in li, we want to print I, and then if I is equals to, let's say 6, we're gonna break. Let's run that. And you see we stopped our loop when I equals 6. If we don't want to include the 6, we let that be the first line of code in our for loop. So it's gonna check if I is equals to 6 and then it's gonna break. And let's write our print here. And you see the difference of when we put the break before and after the print. Now let's move on to break statements in while loop. So let's create a while loop. X equals 1. And while x is less than or equals to 8, we want to print x. Don't forget in while loops, we need to increment. So x plus equals to 1. And now let's add our break statement. So I'll put it in between here. So if x is equals to 5, we're gonna break. Let's run that. And you see it printed our loop first. And then when x was equals to 5, we stopped it. Let's put the print function after our break. Control X to cut, Control V to paste. And let's run that. And you see if x equals 5, it's gonna break. And then it's gonna print our loop. So that's the break statements in while loop and for loops. So now let's move on to the continue statement. And with the continue statement, we can stop a current iteration in a loop and continue with the next. In other words, skipping an item in a loop. And this can be done for for loops and while loops. So let me create a for loop and store some names in a variable. Now let's create our for loop. So for x in names, if x equals Chris, we're gonna continue. And then we're gonna print x. And let's run this. And you see Chris was skipped when we use the continue. We can skip more than one items in the loop. So let's set x equals to Luca, and let's run that. Oh, we need to use our OR operator. Let's run, and you see Chris and Luca was skipped. In the for loop, the continue statement should be used before the print statement, or else it won't skip what we tell it to skip. So let me just show you this. And let's say we put our print first. And let's run that. And you see it didn't make any skips. It didn't skip what we took, the names we told it to skip. So the print function should always come after the continue statement. Now let's move on to continue statements in while loops. So let's create a while loop. So we're gonna write while x is less than 10. Let's increment x. So x, add and assign 1. And if x is equals to 6, we're gonna continue. And then print x. And let's run that. And you see we skipped 6. We can add some more things that we want to skip, or x equals 5, or x equals 7. Let's run that. And you see it skipped the values that we want to skip. And in while loops, the continue statement should be used before the print function, or it won't work. So let me show you. Let's put this here, and then let's print. And you see when we put the print function before the continue statement, it doesn't skip the values that we want it to skip. So the print function should always be after the continue statement. Let's run that. And you see our while loops worked. So this is the continue statement in a nutshell. Now let's move on to creating one-dimensional and two-dimensional arrays with NumPy. But first I'm going to give you a short overview. So NumPy is short for numerical Python, and it works primarily with numerical data. So a one-dimensional array is like a grid of values. It's like a list, and similar to a list, it is ordered mutable and it's enclosed in block brackets. One of the differences is that the values in a NumPy array needs to be of the same data type. So now a two-dimensional array is like a list of lists. It's arranged in rows and columns, and the 0-axis represents the direction of the rows, and the 1-axis represents the direction of the columns. The benefits of using NumPy arrays over lists is that they can be stored more efficiently, and they're useful when working with large amounts of data. So let's create a 1D array. But before we do that, we need to import the NumPy library. So we do that by import NumPy. And since we don't want to type out this whole NumPy word every time we refer to a function in NumPy, we write as np. So now we always only use np when we're calling NumPy functions. So let's run that. And you see everything is fine. So now let's create a list and then convert it into a NumPy array. So I'm gonna create a variable li, and our list is 1, 2, 3, 4, 5. Then I'm gonna set li to np. We're calling what we imported NumPy as np.array. And in brackets, we put our variable. And now let's call our variable. And you see it is an array. Let's see the type. And you see it gives us a NumPy one-dimensional array. Let's look at the shape of this. And one way we could look at the shape, we type np.shape, and in brackets, we put our array. And let's run that. And this means that there are 5 elements in each row. But it is a one-dimensional array, so there's only one row. A better way to do this is just by calling our variable period shape. Let's run that, and we get the shape of our array. We can also create an array by just passing a list into our function. So np array, and our list could be 6, 7, 8, 9, 10. Let's run that, and you see we have a NumPy array. Another thing we can do is turn a tuple into array. So np.array. In our previous lessons, we know that a tuple is surrounded by brackets. And let's run that, and you see it is an array. Now let's move on to creating 2D arrays. And let's create a variable called rnp.array. And then we're going to put our 2-dimensional arrays. 2, 2, 2. When creating 2-dimensional arrays, we need to put it in a nested list. So we need to surround all of this with block brackets. So we put one here and one here. And now let's call our array. And you see we get a 3 by 3 matrix. On the 0 axis, there's 3 rows, and on the 1 axis, there's 3 columns. Let's look at the shape. The first arguments represent the 0 axis, which is 3, and the second argument represents the 1 axis, which is also 3. Let's make some changes. Delete this, run this cell, and run this cell. And you see on the 0 axis, we have 2 elements, and then the 1 axis, we have 3. Let's pass in variables with stored lists into the array function to create a 2-dimensional array. So let me copy this here, bring it here, set li2 to 6, 7, 8, 9, 10. And now let's pass in our variables into our function. So let's create a variable array2, np.array. I'm going to pass in our li variable and li2 variable. And now let's look at that. Oh, we need to surround this with block brackets. Now let's run that. And you see we got our 2-dimensional array. Let's take the shape. And you see we have 2 rows and 5 columns. The 0 axis is 2 and the 1 axis is 5. Let me go through one more additional topic. This is a 1D array. So R1, set that equals to np.array. Let's put in a list, 1 on 1. And I want to say this is a 2D array. I want to set R2 to np.array. And I'm also going to set 1, 1, 1, 1. If we want this to be a 2D array, we need to make it a nested list. So we do that by putting it inside block brackets. So now let's run that. And let's look at the shape of R1. And it tells us that it is a 1-dimensional array with 4 elements in 1 row. And now let's check the shape of our 2D array. And you see it tells us that it is a 2D array because the 0 axis is 1 and the 1 axis is 4. Let's take a look at it. And it's a nested array. Welcome, I hope all is well. And we're gonna go over slicing and indexing in NumPy arrays. So first we're gonna index a 1D array. So let's create an array. Create a variable np.array. In brackets we put blocks and we put our values. Now let's call out our array. And you see here we made our array. So if we want to index, let's say we want to get the 7th value, we will just type in the index position inside of block brackets. So 0, 1, 2. And this is in the second position. Let's press. And you see we get 7. Let's get 0, 1, 2, 3, 4, 5. It's in the 5th position. If we want this 3, we would have to put 0. So now let's move on to slicing. And similar to this, we use the start, stop, and step position inside of square brackets. So now let's do that. So let's say I want from the 0, 1, 2, 3, 4, from the 4th index to the rest of my lists. R2, colon, and we leave that blank, which means that it's going to get the rest of the values in the list. And you see we started from the 4th position. Let's say I want from the 6th to the 8th. So the 6th is in the 1st position, and the 8th is in the 0, 1, 2, 3, and it's in the 3rd position. But with the stop value, the index is exclusive. So 0, 1, 2, 3. We would have to actually put 4 here because in the stop argument, the indexing is exclusive. So let's run that. And you see we got what we wanted from the 1st position to the 4th. If we want, we could also reverse the array by putting a -1 step. And let's run that. Oh, we need to add our stop and our stop. So we're getting everything in the array, but we're just reversing it with a -1 step. Let's run that. And you see it's reversed. So now let's move on to slicing in a 2D array. I'm just gonna copy something I already have and paste it in. And this is a 2D array. So let's look at that. Then you see we have our 2-dimensional array. So index and slicing in 2D arrays requires rows and columns index. So R2. And let's say we want this 50, 0, 1. So it's the index position of 1 and the 50, 0, 1. And this will also be 1. And let's run that. And you see we get the 50. Let's say we wanted to get the 69. 0, 1, 2. The index position is 2. And the column is 0, 1, 2, 3. Let's put 3 and we get 69. Let's do some slicing examples. So R2. And let's say we want to get the last row. We would start from the 0, 1, 2. From the index position 2, we put our colon and we leave it blank because we want all the remaining from position 2, but we don't have any more, so it's going to bring the last row. So 0, 1, 2, and then the next argument is the columns. So we said we want all the columns. So to do that, we just put our colons and we don't put anything in front or behind it. And let's run that. And you see we got our last row. Let's get the first row. So our first row is in index position 0. So we want to start from 0. And remember, the stop argument, it's exclusive. We would have to put 1 if we wanted this last row, because if we count 0, 1, the stop argument is exclusive and it will bring back this first row. So now let's run that. And for the columns, we're gonna leave this because we want all our columns. And let's run that. And you see we got the first row. Let's say we want from index position 50 to down. We would count our indexing 0, 1, 2, 3, 4. And we leave the stop argument blank. And let's run that. And you got 50, 37, and 4. Let's say we want from 0, 1, 1. Let's say we want from 6 to 8. So the index position is 0, 1, 2, 3. It's exclusive, so we will have to put 4. Remember, at the right side in the column, the stop position is exclusive. So we want 8, 0, 1, 2, 3, but we have to put 4. So from 6, 7, and 8. And let's run this. And you see we got 6, 7, 8. Let's say if we want this row and this row. So we start 0, 1. So we'll erase this. And we want to start from our 1. And we're going to leave it blank. And it's going to get the rest of the rows in the array. And then I said we want from here to here. So the index would be 0, 1, 2, 3. So let's put 3 right here. We're starting from 3 and we're gonna go down the rest of our columns. So let's run that. And like I said, we got these values here. Let me do one more example. Let's say we want to get the middle row. We would start with 1 and we want to end at 0, 1, 2. So we'll put 2 here, but it's gonna bring up our 1 index because the stop is exclusive. This is highlighting row 2 or 0, 1, the row in the 1 index. And then let's remove this 3 to get all the columns in that row. So let's run that and you see we got it here. Let's say we want to get 52 to 20. So 0, 1, 2, 3, 4, 5. And we put 5 here. The start index is not exclusive. So let's run that. And you see we got those 2 values here. So now let's move on to Boolean array indexing. First, let me copy this. Let me just change this to 1. And let's run that. So let's create a conditional statement that returns a Boolean array. So we put R1. Let's put more than 3. And let's run that. And you see so 3 is not more than 3, so we get a false. And all the rest of these values is more than 3, so we get a true. We can also filter out to only bring the values that's more than 3. And so we do this by surrounding this in block brackets and putting our variable in front. And let's run that. And you see it only brings the values that's more than 3. So the same with a 2D array. R2, let's look at that. Let's do conditional statement. R2 is more than 10, and it will bring us true and false values. False where it's less than 10, true where it's more than 10. And now let's only extract the values. And let's run that. And you see a flattened 1D array is returned when we filter Boolean array. So let's look at the shape of this. Let me just copy it, paste it. Let me write dot shape. And we see it tells us that it is a 1D array with 12 elements. We can reshape it back to a 2D array with the reshape function. So let me paste this, dot reshape. And in between brackets, we put the amount of rows and columns that we want. So let me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm gonna give this 2 rows and 6 columns. And let's run that. And now you see our array has been reshaped. Now let's move on to array manipulation functions. And the first function we're gonna go over is the reshape function. As you see here, I put a one-dimensional array into an x variable and a two-dimensional array into a y variable. Let's look at x. Let's look at the shapes. And you see our x is a one-dimensional array with 10 elements, and our y is a 2x5 matrix, or 2 rows and 5 columns. So now let's use our reshape function, and let's reshape our 1D array to be 2 rows and 5 columns. So let's run that. And you see we took our 1D array and we turned it into a 2D array. Let's look at the shape. And you see the reshape function changes the shape of our 1D array. Let's try to shape it into a 3x3. So x dot reshape 3x3, and we will get an error. Let's run that. And we got this error because we can only reshape an array to a shape that will fill the array. So a 3x3 won't shape an array with 10 elements. We could do 5x2, and that should work. And here you have it. Now let's move on to the flatten function. And the flatten function converts a 2D array into a 1D array. So our 2D array is y. Let's run that. And now let's flatten that. And let's run that cell. And you see we converted our 2D array into a 1D array. Let's look at the shape. Let's run that. And it's a 1D array with 10 elements. Now let's move on to the transpose function. And before I do that, I want to create some more variables. A equals so I'm creating a 2x2 matrix for A and a 3x3 matrix for Y. I mean a 3x3 matrix for B. And let's look at A. Our mistake here is we didn't nest. It's missing some. We need to surround this by brackets. And let's run that. And you see we got our 2D array. Let's see the shape. And you see it's a 2x3. Let's look at B. Let's look at its shape. And it's a 3x3. So let's look at our A again, and we're gonna transpose this. So A dot transpose, and let's run that. And you could see the rows has been transposed to the columns. Let's check the shape. And it should be, and you see we have 3 rows and 2 columns. And up here before it was transposed, we had 2 rows and 3 columns. And the transpose, we flipped that. Now let me add another list here. And let me run that. Now let's look at B again. And it's a 4x3. Let's look at the shape. And you see 4 rows, 3 columns. And now let's transpose that. Let me just copy this. Paste it here. B. First, let's look at the transpose. And you see it's been switched. Let's look at the shape. Let's run that. And you see it gives us the shape of our array after it's been transposed. Now let's move on to array creation functions. And the first functions we're gonna go over is the full function. And we can use the full function to create an array and fill it with a specific value. So let's create np.full. And the first argument takes the matrix that we want. So I want a 3 by 5. And the next argument is what you want to fill it with. So let's fill it with 8. And let's run that. And you see we made a 3 by 5 numpy array. Let's have some fun. Let's do a 10 by 10. And we want to fill it with 9, 9. And here you have it. The next function I want to go over is the arange function. And the arange function can create a one-dimensional array with even space values. So let's create a range. I want it to start from 0 up to and not including 20. And then I want it to go by 2s. So let's run that. And you see it started with 0 up until but not including 20, and it's going by 2s. If we want 20, we go one more higher. And you see we got the 20. Let's count from 0 to 100 by 10s. Let's run that. Actually, we said 100. So we want 110 here. And you see we counted from 0 to 100 in tens. If we want, we can reshape this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me make this 10 values. Let's run that. And then we can, if we want, we can reshape this 1D array. So let's reshape. And we want 2 rows, 5 columns. Let's run that. And you see we got 2 rows, 5 columns. Now let's move on to the rand function. With the rand function, we could specify the shape and populate the array with random values. But those random values are only between 0 and 1. So let's write np.random. Then we have to type .rand. And let's populate a 5 by 5. And you see we made a 5 by 5 matrix with values between 0 and 1. Now let me show you another function called randint. And with the randint function, if we pass a lower bound as the first argument, the upper bound as the second, and the third is a tuple for the shape of the array. So let me create np.random.randint. And the first argument takes the range. So I want numbers between 5 and 20. And then I want it to be a 5 by 5 matrix. So let's run that. And you see we get a 5 by 5 matrix with random numbers between 5 and 20. So these are some array creation functions. Now let's move on to mathematics in NumPy. So I'm going to import NumPy and run this cell. And I'm just going to paste some arrays that I already made. So we can add arrays that have the same dimensions. So let's call out our array, R1. And let's run that. Oh, I need to run this cell. So run this, and then run this. And then you say we added our array. Another way we can do this is with the NumPy add function. So add, and we put in the arrays that we want to add. So let's run that. Oh, I'm supposed to put numpy.add. So let's run that. And you see it does the same thing. And we can also add multiple arrays together by just adding one more. Let's run that. And you see we can add as much as we like. When adding arrays, the one axis should be the same. it needs to be the same to be broadcasted. So let's try this. Add array 1 plus array 2, and we'll get an error. But since array 3 and array 1 has the same rows, we can broadcast array 1 to array 3. So let's run that. And we see array 3. We broadcasted array 1 to array 3. Let's take a look at array 3 and array 1. And you see 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 4 equals 7. 3 plus 5, 8, and so on. The same with the second row. 1 plus 6 is 7. 2 plus 4, 6. 3 plus 3, 6, and so on. So we broadcasted array 1 to array 3. We can also add scalar values. So let me just take a look at my array. Let's say I wanted to add 10. Let's run that. And we added 10 to all of our elements in the array. Let's say we wanted to add or find the sum of all the elements in array 3. We'll write np.sum, and in between brackets we put in our array. And let's run that. And you see the sum of all these values equals 63. Let's look at our array again. And let's sum all the elements on the 0 axis, meaning that the columns will get summed up. So we put np.sum, and then we put in our variable, and the next argument we put in the axis equals 0. And let's run that. It's supposed to be np, and let's run that. And you see it summed up the column. So 2 plus 6 is 8, plus 2 is 10. 3 plus 4 is 7, plus 3 is 10. 4 plus 3 is 7, plus 4, 11, 5, 5, 5, 15, and so on. If we want to sum up the rows, we put np.sum r3, and we set the axis to 1. Let's run that. And you see 2 plus 3 plus 4 plus 5 plus 6 is 20. This row, if we sum up this row, it will be 21. And if we sum up this row, it will be 22. We can also find the mean of the values in our array. So array3.mean, and let's run that. And you see the mean of the elements in our array is 4.2. Let's find the mean of each column. np.mean our array 3, and the next argument, the axis equals to 0. And let's run that. And you see the average of each column. Let me just copy this so we can find the mean of each row. And we just change that to 1. And let's run that. And you see we get the average for each row of elements in our array. Let's call in our array 3 again so we can watch it. And let's say we want to get the maximum of each row. We would write np.amax. We call in our array, and we said we want the row, so we set the axis to 1. And let's run that. And you see we get the max value for each row. So the max value here is 6, 6, 8. Let me copy this, paste it here. Now we want for the column, and let's run that. And you see the max of the first column, 6. This one has 4, 4, 5, 8. We can also do the a min. So I'm just gonna change it here. Let's run that. And you get the minimum value in the rows. Now let's get the minimum value for each column. Let's run that. And you see we got that minimum values. Now let's move on to Pandas. And Pandas is a Python library that is used to analyze data. So the first topic we're gonna go over in Pandas is Pandas Series. And a series is like a column in a table. It's a one-dimensional array and it can hold any type of data. Before we do anything in Pandas, we need to import it. Import pandas as PD. And since we don't want to type out this whole pandas word every time we want to refer to a function in the pandas library, we type as PD. So let's run this. And now let's create our series. So x equals and now let's create our series. So we call PD what we imported pandas as dot series with a capital S, and in brackets we type in the data keyword, and then we put our variable where we stored our list. So let's call out our series, and you see here we have the series. Let's look at the type, and you see it tells us that it's a pandas series. We can also index, so let's say I want the 200 value. Let's call this out. And let's say I want this 300 value. I just call in the index number position. So x2, let's run, and you see we got the 300. We can also name our indexes instead of it getting the default numbers. So I'm gonna create another variable with the index names. I know I'm supposed to be giving these capital letters, but it's just a tutorial. So let me create a new variable called new equals pd.series, and in brackets we want the data to be x, and we set the index to our days variable we just created. And now let's run new, and you see we renamed our indexes. We can access any value, so let's say if I want Friday, call in the new, and we put in between quotes, we put our index name. And let's run that, and you see we got the value. We can also access multiple values, so let's say I want Friday, Tuesday, and Monday. And then we have to surround this with block brackets. And let's run that. And you see we access multiple values. As you can see here, the data type is currently integer 64. We can change this by adding a third argument. So let me just copy this, paste it here. Then we could add set the D type to, let's say we want it to be a float. Now let's run that. And now you see the data type of our series, of the values in our series, is a float. We can also create series with dictionaries. So let me show you. So we're gonna create a dictionary. We're gonna set John to 5, Ron to 4, and then Sally to 8. Now let's run that. And when we're creating series with dictionaries or key value pairs, the keys is the index and the value is the data. So let's create a series from our dictionary. So pd.series, and we can put data equals D. And let's run that. And you see we created a series with our dictionary. We don't have to put the data equals. We can remove that. Let's press Shift Enter, and you see it does the same thing. So this is Pandas Series. Now let's move on to Pandas Dataframe. And a Pandas Dataframe is a two-dimensional data structure like a 2D array or a table with rows and columns. So before we create our data frame, I put my index in the IND variable, my columns in the COL variable, and our data. And from what you can see here, our data will have 1, 2, 3, 4, 5 rows and 3 columns. So let's run this. And now let's create our data frame. So PD, remember we imported pandas as PD dot data and frame with a capital F. And we're gonna set our index to our IND variable. The data equals the data, and equals call. Let's save this into a variable. Let's call out our variable. And you see we created our data frame. Let's look at the type. And it should say it's a data frame. Now let's move on to a function called a setIndex. And the setIndex function can set an index using existing columns. So let's set column C to the index. Call out our data frame dot set underscore index. Put our brackets, and in between quotes we put column C. And let's run that. And you see now column C is the index. And you see by default that it dropped column C. So if we wanted column C to remain, let's copy this, paste it here. We would have to add the drop equals false argument. And now let's run that. And you see it kept our C column. But as you can see, let's call out our data frame. And you see the changes wasn't made to the data frame because we can add one more argument into our setIndex object. So let me copy this, paste it here. And now if we want our data frame to save these changes, we write in place equals, and we set that to true. And now let's run that. Now let's call out our data frame. And you see now the changes has stayed. Now let's move on to the reset index. So I'm gonna set the index back to 0, 1, 2, 3, and so on. So now let's call out our data frame dot reset underscore index. And in between brackets, we have to use the drop equals true argument because by default, the drop arguments is false. And we cannot reset an index with an already existing column. So let me just show you. All that, let's run. And you see we get an error. And it says you cannot insert C because it already exists. So we need to use the drop column argument. So now let's set the drop equals to true. And let's also set our in place to true. And let's run that. Let's call out our variable. And you see our index was reset. So that's Pandas Dataframe. One more thing we can do is read CSV files, export files, JSON files, and so on. So now I'm going to show you how to import a CSV file into a data frame. So now let's import our CSV. So I'm going to set x equals to pd.read underscore CSV. And in between brackets, and also in between quotes, we put the name of our CSV file. And the name of our CSV file is top 10 countries. So top 10 countries. And this file needs to be in the same file as the Python file that you're working on. Let me just show you pandas, rename. And you see it's in the same folder as the Jupyter notebook script that I'm working on. So let's run that. And now there's an error. Okay, I needed to add .csv at the end because it's a CSV file. And let's run that. And now let's call out X. And you see we loaded our file into Pandas Dataframe. So now let's move on to selecting data in Panda. So the first thing we have to do is import Pandas. Let's run that. And let's import our data. So I'm going to call our variable countries. pd.read underscore CSV. And the name of our file is top 10 countries .csv. Misspelled countries. Let's call out our countries variable. And you see we put our CSV inside our countries variable. So now let's go ahead and select one column. So let's say I want to select the region column. I'm going to go countries and then brackets and then colon. I'm going to put in the region column. And now let's run that. And you see we get our column. Another way we could do this is putting a period and then our column. Let's run that. And you see we get the same thing. The only thing about using this method is that we can't do columns that have names with space in between them like this. For ones like this, let me just show you. We'll get an error. For columns like this, we need to surround it with brackets and in single or double quotes. Oh, I need to remove this period. And let's run that. And you see we got our column. Let's copy this. And look at the type. And you see that it is a series. A single column is a series. And a data frame is a collection of series. So now let's move on to selecting multiple columns. So let's call in our data frame countries. And inside of two block brackets, we can put in a list of our columns. So region, country, let me just paste let me see what other columns. Let me just get the date. I need another block bracket here, and let's run that. And you see we get multiple columns. We can also select rows by the index position using the iloc function. So countries dot iloc, and in the block bracket we put the index position. So let's say we want 4. And let's run that. And you see we get the 4th index. We can also slice. But first let me just call in our data frame. So let's say I want to slice from the 5th index down. I'll simply put 5 colon and leave the other side blank. And let's run that. And you see we got from the 5th index down. We can get from the 5th to the 8th. Oh, the reason why we don't get 8 is because the stop argument is exclusive. So if we wanted 8, we would have to put 9. We can also index rows and columns. So countries dot iloc 6 2. And you see it's Africa because it's in the 6th index, 0, 1, 2. It's in the 2nd index. Let me just remove this so we can see our data frame. And we can slice rows and column. So let's say I want from the second index, and I want columns from 1 to 0, 1, 2, 3. Let's run that. And you see we get from the second index down, and we get from column 1, 2, 3. And we know the 3 is exclusive. The log function requires labels and names. So let's say countries.log. We can't put index positions, but we have to put the names. So I'm gonna say I want from index 3 to 6. So it's gonna bring 3 to 5. So 3 to 6. And then I only want the region column. So let's put the region. Now let's also put the population. Comma. And now let's run that. So the log function requires label names. It doesn't accept index positions. So now let's move on to conditional selection. Let's call in our countries data frame. And let's say I only want to return the rows where the region is Asia. So I would call in my variable, and in between block brackets, I'll call out our countries, our region column, and then I'll set that equals to Asia. And let's run that. And you see we only got the rows where the region is Asia. We can also do Africa. Let's run that. And you see we get one row because Africa is the only region in this table. We can combine multiple conditions using the AND and the OR operator. So let's do that. So I'm gonna create countries and then block brackets. And I'm gonna take this. Then I'm gonna put the AND sign. And then I'm gonna say I want where the countries column population is more than a certain amount. So I'm gonna write countries population is greater than, let me say 300 million. And first we need to surround the two statements with brackets. This one is already surrounded with brackets. And now let's run that. Let's see what's wrong. Oh, the P is capitalized because in our column here, it's a capital P and I put a lowercase. So let's run that. So Africa's population is not more than whatever we're asking for here. So let me put Asia. Let's run that. And you see we bring up the rows that satisfies our conditions. If we wanted to use the OR instead of the AND, we use this. And let's run that. And then you see it brings us the values where the region is Asia or the population is over 300 million. We can add additional filters, like if we only want certain columns. At the end of here, we open two block brackets. The one inside is our list, and we'll put a list of our columns. And let's say I want the rank country/dependency, but I'm gonna copy this. Control C, in between quotes. And now let's run that. And you see we get the columns that we asked for. We can also select rows that match a list of values. So let me call our countries variable. And let's say I want to bring the rows where the region is Asia and Americas. Let's call out our data frame, and in between brackets, we call out our region column. And then we're gonna use the isIn method. And it will take the list of the rows of Asia and Americas. So create this list, Asia, Americas. And let's run that. Oh, we need to capitalize because Americas is with a capital A, Asia is with a capital A. And let's run that. And you see we brought the rows where the region is only Asia and Americas. Some few other things. Let's call out our data frame. And let's say we only wanted to bring the top 5 rows. We would write countries dot head in brackets. And let's run that. And it brings us the top 5 rows. Let's say we only want 2 rows. We would put it here. And then let's run that. If we wanted to bring the last 5 rows in our data frame, we write countries dot tail, put in brackets, the default is 5, the last 5. And you see here it brings in the last 5. Let's say if we want the last 3, it brings the last 3 rows in our data frame. Now let's move on to data manipulation in Pandas. And before we do anything with Pandas, we have to import it. So let's import Pandas. And let's put a CSV into our data frame. pd.read_CSV. And the name of our file is countries.csv. This file will be available for you to download if you want to follow along. So now let's look at our data frame. Oh, the name of our file is top 10 countries. See it here, top 10 countries.csv. Now let's run that. And you see here we have our data frame. To check the shape of our data frame, we could just write data frame shape. Let's run that. And you see it's 10 rows and 6 columns, like we see up here. To check the data types, we write df.dtypes. Let's run that. And you see the data types of the columns in our data frame. If we want to check the columns, we could simply write dataframes.columns. So now let's move on to renaming a column. And to change the column name in the data frame, we use the rename method. So let's look at our data frame. So let's change the name of this column here. So we say dataframe.rename. And in between brackets, we put the columns and we put it like a dictionary. So we put our countries/dependency. And then we put what we want to change it to. We only want to change it to country. And then we want to set in place to true so the changes stays in our data frame. And now let's run that. And you see the column name was changed. To delete a column, we use the drop argument. So let's call our data frame .drop. And let's say we want to drop the date column. In between braces, we put column equals date and set the in place to be true. Now let's call our data frame. Let's run that. And you see the date column was deleted. And let's move on to add a column. Let's add a column called population in millions. So we rel our data frame, and then we put what we want the name of our columns to be. So population in millions. And what we want this column to have, we want to divide the population column by 1 million. And then let's round it to 2 decimal places. So let's put our data frame. We want our population column. And we want to divide that by 1 million. And then we said we want to round it by 2. And the round takes 2 arguments. It takes whatever we want to round. And the next argument is the decimal places. So we want to round it by 2 decimal places. And now let's run that. And you see we created our column, which divided the population by 1 million and rounded it by 2. Let's create a column that joins 2 string columns or 2 object columns. Let's create a column called country/region, and we want to put the countries / the region. So let's create our column, and we want country/region. And what we want in that column, we want the values in the country column. It's a capital C. Then we want to add a slash, and then we want to add the region column. And let's look at our data frame. Oh, we need to put this in between quotes. So now let's run that. And now you see we created our column that joined the values in the country and region column. So now let's change the data types of a column. Now let's check the data types of the column. And you see the percentage of the world is an object. So let's change it to a float. But before we do that, we need to remove the %sign. So let's create a function to remove the %sign. And then we want to return x, and we're gonna do a negative step value. So now let's run that. Let's call in our function. Now let's put a value in our column. And let's run that. And you see the %sign was moved. So now let's use the apply function to apply it to our column. So let's call our percentage of world column. Let me see that I'm spelling it right. We're gonna write dot apply, and then we wanna apply our function that we created. Now let's run that. And you see it removed the % in the column. So now let's assign it to our column. We call out our column. And we set that equals to what we did here. Now let's call our data frame. And now you see the percentage was removed. Now let's check the data type. It should be the same. And we see that it's an object. So now that we remove the %sign and it just has the decimal, we can change this column, its data type, into a float. So let me just copy this. And we set that equals to the column. And then we use our asType function. And then in brackets, we write float. So now let's check the data type. And you see the data type for the percentage of the world column was changed. So now let's deal with datetime columns. But before we do this, let's load another CSV file. And the name of our CSV is cyclohires.csv. We need to put it in between quotes. Now let's call out our variable. And you see we get our data frame. I want to drop this column. df2.drop columns, and we set that equals to the name of our column. And we want to set the in place to true. Now let's call out our data frame. And you see the column was dropped. Let's look at the data type. And we see that the day is an object. So let's change that into a datetime data type. So one way we could do this, let's set our variable and we set that equals to, we want our day column. And then we use the as type function and we want the datetime data type. So now let's run that. Oh, we actually need to, because we want to change the column. Let's remove that period. And now let's run that. And now let's check the data types. And you see we changed the data type for our day column. It was an object, now it's a datetime column. Another way we can do this is with the toDatetime function, and we won't get this error. Now let's set that to pd.to_datetime. And in between brackets, we put our column. Now let's check the data types. It will do the same thing, but without the error. So it's better to do it this way because you see we get this little warning message. So to change a column into a datetime data type, you should just follow this way. We can use the datetime model to convert a datetime data type to a string. And when we do that, we can display the dates as months or year. But first we need to import datetime. So let me do that. And let's run that. And now let's look at our data frame. Actually, our second data frame. And let's say we want to extract the month and the year from this date. All right, call it our column, day, dt.strf time, and in between brackets, we put a percentage and B, and the percentage B is the format code for the month. Percentage Y is the format code for the year. Let's run that. Oh, we made a mistake here. It's DT, not DF, datetime, because we imported it as DT. Now let's run that. And you see we got the month and the year. So now let's add this into a new column, and we're going to call our new column month/year. And we're going to set that equals to what we just did here. Let's copy this, paste it, and now let's look at our data frame. And you see we made a month and year column, and we extracted the month and the year from our day column. So now let's move on to sorting the values, and let's sort the values by the number of bicycle hires in the descending order. Let's call out our data frame, and then we use the sort values function, and in brackets we want it by the number of bicycle hires. I'm just going to copy this, and by default it comes in ascending order, but we want it in descending order. So we have to write in our ascending argument equals false and set the in place to true. And now let's look at our data frame, and you see it's sorted in descending order by the number of bicycle hires. If we want it in ascending order, we just remove the ascending argument, and let's run that, and you see now it's in ascending order. If we want to see the first 5 rows in our data frame, write df2.head, and by default it brings up 5. If we want 2, we just put in the number in between the braces. If we want the last 5 rows, we use the till method, and let's run that, and see we get the last 5 rows in our data frame. If we want the last 3, we just put the value in between the brackets. One more thing I'll show you, df2, we could transpose the rows and columns, which simply means just flip it. So let's write our data frame dot transpose, and let's run that, and you see we flipped our columns and index. So now let's move on to data aggregation and grouping. But before we do that, I want to do some data manipulation so we can get the data frame how we want it. So we're going to read our CSV file. And you see we loaded our data frame. So let's drop some columns. I want to drop the percentage of the world and the date column. So you see the drop columns equals to, so I want this. I'm just going to press Control C to copy it and Control V to paste. And the next one will be date. And we want to set the in place to true. Let's run that. Let's look at our data frame. And you see we dropped the columns. Let's rename the country/dependency to country. So c.rename columns equals, I'm going to use a dictionary. Let me just copy this. And we want to change that to country. And set the in place equals to true. So it saves our changes, and let's look at it. And you see the column has changed. Let's see the data types. So let's change the column and region column into a string data type. So C, and in between double block brackets, we put the name of a column country and the region. I'm gonna set that equals to, just gonna copy this and put it on this side. Control C to copy, Control V to paste. And then we use the as type function and we say we want it to a string. And now let's look at our D types after that. Here, let's run that. And you see it's been changed to a string. So let's create a column called subregions, and I'm gonna paste some values. Put it here. And then we're gonna add this to our data frame. So our C And our column name that we're gonna add is subregion. It only needs one bracket. Then we set that equals to what we stored in this variable here. And now let's look at our data frame, and you see we added the subregion. Let's look at the data types. Let's run that. And let's change the data type for subregion from an object to a string. So I'm gonna copy this. And I'm gonna paste this again. And I'm gonna add as type string. Let's see our data types now. And you see we made the changes. Let's use the reindex function to reorder our columns. So set C equals to C dot reindex. Let's set our columns equals to, let me take a look at our data frame. And I want subregion here. So let me just pass it in as a list. Rank, country, the population. Now let's look at our data frame, and you see we made the changes. Now we can move on to aggregation functions. So let's perform some aggregation on a numeric column, and let's do it to our population column. So if we wanted the mean, simply call in our column population dot mean, and let's run that. And you see we get the mean. We can also get the max, the min, the sum, standard deviation, and also the count. We can also use the describe method to return all descriptive statistics. So I'm gonna just copy this. And here I put describe. And you see we get all the descriptive statistics. We can also apply it to our data frame, and it will only bring up the descriptive statistics for the numerical columns. So there's only 2 numerical columns in our data frame. We can apply the max and min to a string column, and it will bring the first string that's in alphabetical order. So I'll just look at this. So let's say country, and we want the min. Let's try the subregion. And you see we get Central America. So you see here it brings in Central America because in alphabetical order it's the first. If we bring the max, we get Western Africa. Now let's move on to the unique function, and it returns a list of unique values for a column. So let's say we want the unique values for the region column. We call out our column and our unique function. Let's run that. And you see we get the unique values, which is only Asia, America, Africa, Europe. And you could see in these columns, those are the unique values. We can bring the number of unique values using n unique. Oh, I meant to copy instead of, I'll just type it again. C dot region. And we want n unique. And let's run that. And you see we get 4. And just copy this and do the unique. There you have it. Now let's move on to the group by function, and it is used for grouping values in a column. So let's look at our variable. Let's look at our data frame, and let's find the total population for each region in our data frame. We will do this by c.group by, and then in brackets, the by keywords, and we said we want the region column, and then we're gonna find the sum. Let's run that. And you see it grouped our data frame by the region, and it brought us the sum of the numeric values. Let's say we want to remove the rank column. I'll just put C, and in between double block brackets, we put the columns that we want to see. And we only want to see region and population. And then we're going to call our group by keyword. Then in between brackets, we put region. Then we want the sum. And let's run that. And you see it only brought the region column and the population column. And it grouped by the countries in the region column. We can group by multiple columns by passing it in as a list in the group by argument. So let me just copy this part. And then I'm going to add sub-region here. Put a comma here. And then we want to group by region and sub-region. So it said equals to region and sub-region. And we have to surround this by block brackets. And then let's add sum. And let's run that. And you see it grouped it by both the region and the sub-region. And it found the sum of our regions and sub-regions. If we want, we can add another column, the min and the max, which brings in a min column, which brings in the minimum values, and the max column that brings in the max. So let's just copy this so we don't need to retype. Press Ctrl C and Ctrl V. And instead of this sum, I'm going to call our agg function. And in between the list, we put the min and the max. And let's run that. And you see we grouped our data frame by region and sub-region. And we applied multiple aggregate functions. So this is aggregate functions and group by. Now let's move on to data cleaning. And here I created a data frame, a dirty data frame that we can practice cleaning with. So this is the data, and I created a data frame, and I set the data equals to, I put up my data into a zip function, and then we put that zip function into a list, and then we set the columns into equals our columns here. So now let's run that, and you see we got our data frame. So one thing we should do is check our columns for white spaces. So let's look at our employee column. You have .employee, and let's run that. And you see we have plenty white spaces before and after. One way we can fix this is to create a function and pass in the strip method into our function. So let me just show you what I mean. Employee, set that to dfEmployee.apply, and apply takes a function, so I'm going to create a lambda function, lambda x, and what I want it to do is strip, and this is going to strip all the white spaces. And let's run that. Let's look at our employee column, and you see it removed the white spaces. We can check for null values in a data frame by using the isNull function, df.isNull, and then we have to see the sum of those values. And let's run. And you see we have one null value in position and two null values in salaries. And here you see it. One way we could deal with null values is by dropping the rows that contain them. So df dot drop NA. Let's run that. And you see it drop the rows with the null values. If we don't want to drop all the rows, like let's go back here. Maybe we only want to drop 2 rows of null value. We should set the threshold to 2. And we set the thresholds inside of our NA function. So thresh equals 2. Let's run that. And you see it only removed 2 rows that has null values in our data frame. If we want to drop a column with null values, we set the axis to 1. So let me just look at our data frame again. And if we set the, let me just copy this. And if I set the axis to 1, it's going to drop all the columns with null values. Let's run that. And you see the position and salary had null values, so it will only bring up the employee column. Let me look at that data frame again. We can also replace the null values with a specific value. So let's write df dot position dot fill NA. And I want to fill all the NA values with lawyer. Actually, I'm filling all the null values in the position column with lawyer. Put a Y here. And then I want to set the in place to true, so it stays equals true. And let's call out our data frame. Let's run that. And you see it filled in the null values with the lawyer that we specified. Next, if we want to fix wrong data, so let's say we want to change lawyer to accountant. Let me just copy this part here. Control C, Control V. So inside of the column position, we want to make the changes, and we want to replace the lawyer, and then we're going to put accountant as the next argument. So we're going to change from lawyer to accountant. And now let's call our data frame. Let's run that. And you see lawyer has been changed into accountant. So this is some basic data cleaning in Pandas. So now let's move on to Matplotlib. And it's a library for creating plots, graphs, bar graphs, line charts, and so on. But before we do that, we have to create a plot area. And we do that using the figure object. So let's import Matplotlib and run this cell. And let's create our figure object. So I'm going to set fig to plc.figure. And let's run that. And you see we created a figure object, but it doesn't have any axes. So now let's add an axis. So first let me add the axis, and then I'll explain what it's doing. Add underscore axis. And it takes our rect argument. And that takes 4 elements. Or we need to put it as a list. So let's run it. And you see we created our figure. So what axis does is that it takes the rect argument. And the 3rd and 4th element is the width and the height. And by default, the width is 6.4 and the height is 4.8. These first 2 arguments deals with the left and the bottom. We'll only need to change this if we want to add more than one axis. So if we want to cut this into half, we can put 0.5 here. And we'll also cut the width in half from the default. And let's run that. And you see we get smaller. We can establish our own height and width. And we do that with the fig size argument. So again, I'll just copy this, paste it here. And in the figure arguments, we just have to write fig size. And I want to set it to 5 by 5. And then it will return a height of 2.5 and a width of 2.5, because 0.5 times 5 is 2.5. And let's run that. Or we should surround this by brackets. Now let's run that. And you see we got our 2.5 by 2.5. We can assign axis to a variable. So let me just copy this, paste it here, and let's create a variable called axes and set that equals to, and I'm just gonna copy this, Control C, paste it, and let's run that. Oh, we need to put fig. Calling our fig variable that we created here to add the axis onto it. And let's run that. And you see we got the same figure that we got up here. So now let's add two axes. So I'm gonna copy this, paste it here, and call this one axis 2. And let's run that. And we have two axes, but we can't see it because it's overlapping each other. So if we want to bring axis 2 to the right, we need to put a 1 in our right argument. So let's run that. And you see we got two axes in our figure object. Let me change this to 1. Let me make the axis bigger. And let's run that. And you see it's too close to each other because of how big it is. If we want to create some space from the right, we just give this a 1.5. Now let's run that. And you see we created some space. Now let's add labels and titles. So I'm just going to go here. And we'll add titles to both axes. So I'm going to call in our first axis, I'm going to use the set title. And I'm going to call it chart 1 or chart uno. Then let me just copy this, paste it. We want axis, set the title to axis 2. I'm going to call it chart dos. And now let's run that. And you see we added titles to our axes. So let me put title here. And now I want to give labels to our X and Y. So labels. So I'm going to call in the first axis dot set X label. Should be an underscore between set X label. And I'm going to put our X for chart uno. And then I'm just going to copy this. Control V. Change this Y. And then I'm going to change this to our Y for chart uno. Then I'm going to copy both of these because I just don't want to type over and over again. And then I'm going to set axis to 2. And then I'm going to write X label for chart dos. Then I'm going to say Y label for chart dos. Now let's run that. And you see we created our X and Y labels and also put titles in our chart. If we want to remove this, we can write this plt.show. Whoa. And let's run that. And you see it was removed. But there's an easier way to create multiple charts. So let's move on to subplots. And subplots is more convenient than using the figure method. So let me create subplots. And then I'm going to give it 1 row and 1 column. So what this means, that is going to give us 1 plot, 1 row and 1 column. Let's say if we want 1 row and 2 columns, so it's going to give 2 charts side by side. We put 2 in the column argument. And you see it gives us our subplots. We can do 2 by 2. We can also do 3 by 3 if we want, so on. But you see it's all jumbled up too close to each other. So we can fix this with the type layout argument. Type layout, and we set that equals to true. And let's run that. And you see we got some space. So now let's make labels and titles for subplots. I'm just going to do 2 because it'll be a while to create labels for all of these. So 2 by 2. And then we want 2 axes. So the way how we do this, figure, and then we're gonna add our axes in between brackets. So x1, x2, I'm gonna set that equals to PLT subplots. Let's run that. And you see we got our 2 by 2. Let me give 1 row and 2 columns instead. And you see we have 1 row and 2 columns. So let's add labels and titles for the first axis. So I'm gonna call in up the first axis. So axis 1 dot set underscore title, and I'm gonna say our first, and then I'm gonna set the Y label. Then I'm gonna call that height. Gonna set the X label. Call that age. So let me run that. And you see we labeled our, or we didn't get the X label because I made a mistake here. I'm supposed to put X label here. Let's run that. And you see we got the age. So now let's set the labels and titles for the second axis. So let me copy this. Paste it here. For the second axis. Then I'm gonna change this to x2. Call this our second. I'm just gonna call these cars, mile. And let's run that. And you see we did the labeling and titling for our second axis. We can also change the size of this by adding the fig size method. So fig size equals, I'm gonna give it 12 by 8. Let's run that. And you see we gave our figure a bigger size. Let me give it 8 by 4 to see what it looks like. And that's a little better. If we want to change the font size, we could do this with the font dict argument. Set that equals to a dictionary font size. And we want to give it size of 20. I'm just going to copy this. Paste this here. And I'm going to do the same for here. And just set these to 15. And now let's run that. And you see our changes has been made. In the next lesson, we'll go over how to create a bar plot. So now let's move on to bar plots in Matplotlib. But before we create a bar plot, we have to make some changes to our data frame. So here we imported Matplotlib as PLT and Pandas as PD, and we loaded our CSV into a data frame. And we were bringing up the top 5 rows in our data frame. Here we renamed the country column to country, and we set the in place is true so that the changes remain in our data frame. And then we created a new data frame, and we only wanted the region column and the population column. And you see we have it here. And then we grouped by our region column, and we want the sum of the populations that we grouped by the region column. And you see we got this data frame. And next we reset the index, because here the region column is the index. And then when we use the reset index function, region and column becomes its own columns. So before we create a bar plot, we have to create a figure object. area. So we set fig equals to, set the fig size to 5 by 5. Let's run that. And you see we created our plot area. Now let's add our axis. And we're gonna set this as 1, 1 because we want the plot size to be 5 by 5. If I set this to 0.5, it will be half of the figure size. Now let's set our X label. If you're not sure of what I'm doing here, just refer to the previous lesson and we explained figures, axes, and subplots. So I want to call the label region. I'm gonna call that total population. And then I'm gonna set a title. Axis.set underscore title. Region. And now let's run that. And you see we created our plot area. I'm gonna take this down a little bit. Give this 0.2 or 0.6. Now that's a little smaller. Let me give it 0.4. Now let's go at 0.6. So I'll set it to 0.7. So now let's plot our bars. So here set a note. Plotting the bars. So we call the Matplotlib function plt.bar. And in between brackets, we call our data frame and the region column for the X and the population column for the and let's run that. And you see we plotted our bars. If we want to remove this, we can add plt.show as the last line here. And you see it was removed. If we want to change the colors to our bar plot, we just add the color argument and let's change it to red. And let's run that. And you see our bar plot's been changed to red. We can add a list of colors for each bar. So we put it in a list. And the first one I want to be red. The second one be blue. The third one be purple. And the fourth one could be white. Let's run that. And you see we changed our colors. Let me just erase this because it doesn't look nice. I'll run that. We can sort this in descending order by just sorting the population in descending order in our data frame. So call dataframe 2 dot our sort values function. And we want to sort it by the population column. And then we set the ascending to false, because by default it's in this ascending order, and we change the in place to true. In place equals true. And let's run that. Oh, I spelled ascending wrong. So let's run that. And let me run this cell again. And you see it sorted the bars in this ascending order. So now let's create a horizontal bar chart next to this. And I'm gonna do this using subplots. So we're gonna set our figure. And we put our, I wanna make 2 bar plots. So one axis and axis 2. And I'm gonna set that to plt.subplots. And the arguments is take. is we want 1 row and 2 columns of axes, and then we want the fig size to be, let's set it to 10 by 5. And let's set the tight layout to true. If you don't understand what I'm saying here, just refer to the previous lesson. And let's run this. Oh, I spelled subplots wrong. So put a P here and let's run it. And you see we got our plots. Now let's set labels and titles for the first axis. And I think I'm just gonna copy from this one here. Let me copy this, Control C, Control V to paste. And I'm gonna rename this as AX1. And then I'm gonna set the labels and titles for the second axis. So let me just copy this, paste it here. For the second axis, I'm gonna change this to axis 2. And then I'm gonna make some changes here. I want the Y label to be country, the X label to be population, and I want the title to be total population by country. Let me run this. And you see we created our plot area and gave it labels and titles. So now let's plot our bar. So I'm gonna call our axis dot bar. We're gonna put the same thing here, Control C. Paste it in here. And I'm gonna set this to bar 1 and give our notes for bar 2. I'm gonna call our second axis. And I'm gonna make this second one horizontal. So let me set bar H. And in the brackets, we want the country column in our data frame and the population. And the reason why I put this bar H is because I want it horizontal. So let's run that. Oh, the reason why we're getting this mistake is because I'm calling the data frame 2. I'm calling a column from the data frame 2 that doesn't exist. So this is data frame 2. But I'll call my data frame. So let me just erase this 2. So we call out our data frame. And let's run that. And you see we got both our plots. And you see we got a horizontal bar plots because we used the bar H function for axis 2. So this is how to create bar plots in Matplotlib. So now let's move on to line plots in Matplotlib. So before I create a line plot, I manipulated the data to how I want it to be. So first I imported all the libraries I'm gonna need to do that. And here I imported our CSV file into a data frame. And we dropped a column named unnamed column 2. And then we changed the data type of the day column to a datetime data type. And I sort the values by day. And then I took the year out of the day column and put it into its own column. And then we only put the 2 columns into our data frame. Then here you see we get the 2 columns. And then we grouped it by the year. And we set the aggregate to the sum. So we grouped it by year and the sum of the bicycle hires. So now let's create our line plot. So first we have to create figures and axes. Fig equal to plt.figure. And then we're gonna set the fig size to, let's do 6 by 3. And gonna create our x, set that to fig.add underscore axes, and we only want 1. So we set the up and down to 0, and we want the 6x3 size, so we set these to 1. Now let's run that. Oh, first I need to run, we didn't run this cell, so let me run all the cells. And you see we got our figure. So now let's add a plot. So we call our x.plot, and then we want the year column for the x and the number of bicycle hires for the y. Let me just go copy this. Control C, paste it here. Now let's run that. And you see we got our line. We can set a marker. Marker equals to, and let's just give it a dot. So we put it at O. Let's run that. And we get a marker. To change the color is the same way we did with the bar plot in the previous lesson. So I mean, set color equals to, let's say purple. Run that, and you see we did it. If we want, we could plot another axis on this same figure. So let me copy this and just make some changes to it. So what I'm gonna do is just multiply all of this times 2. And let's run that. And you see we got our second plot. Let me give it a color of red. And you see we changed the color of the second plot. If we want to set titles and labels, x1.set underscore title, and I'm just gonna put number of hires, then set the X label, set that to year, and get the Y label, set that to number of hires. And let's add the plt.show function to remove this. And let's run it. And you see we change our title and axis. So that's how you make a line plot in Matplotlib. So now let's move on to scatter plots in Matplotlib. And before we create any scatter plots, let me just go through the data preparation. So we imported pandas as PD and matplotlib as. Then we stored our players.csv file into our data frame, and here you see our players data frame. But by default, pandas doesn't show all the columns in a data frame if it's too much. So in order to display all the columns, we need to use the pandas set option, and in between brackets we put the display max columns and none as the arguments, and then now you see all the columns is displayed. So now we take the top 100 players from the data frame and we put it in a new variable called df. So what we're gonna do is create a scatter plot, and we're gonna plot the players overall and their wage. So let's first create our figure. So I'm gonna set fig to equal to plt.figure, and we're gonna set the fig size to, let's say 6x4. And next what we have to do is add axis to our figure object. So we're gonna create a variable ax1 and set that equals to fig.add underscore axes, and in between brackets we put 0, 0, 1, 1. The last two ones, it means the length and the width. So since we put 1 here, our fig size will be 6x4. If we had put 0.5 here, then and 0.5 here also, then our figure size would be 3 by 2. So let me run that. Oh, PLC is not defined. I need to run this cell. So let me just run all cells. Let me make this a little smaller. Too small. Yeah, and that's okay. So now let's add labels and titles. Set titles. I'm gonna call it overall ability versus wages. I'm gonna set our X label. Overall ability. I'm gonna set our Y label. Set that to wages. And let's run that. And you see we set our labels. And now let's create our scatter plot. So I'm gonna call in our axis dot scatter. And then we said we wanted the overall column and the wage column. Overall, let me make sure then the wage dot. And let's run that. And you see we made our scatter plot. If you want to remove this, you could type plt.show. We could change the size with the S argument. Let's set that to equal to 20. See what happens. And you see it got smaller. 50. Another way we could do this, let me just copy this. Paste it here. And then we call on the data arguments and we set that equals to our data frame. So let me comment that out. And this will just do the same thing. Let's run that. Oh, we need to put a comma here. Let's run that. And you see it does the same thing. But the good thing about this is, let's say we only want to get the top 10 players in our data frame. We could just put data frame dot head, and in between brackets we put 10. So let's run that. And you see we only plotted for the top 10 players in our data frame. So this is scatter plots. So now let's move on to histograms in Matplotlib, and a histogram can show us frequency distribution. It is a graph showing the number of occurrences of a value within given intervals or bin. So here we imported our necessary libraries, and then we put our players CSV into a data frame. And then we use this Pandas set option so we can view all the columns. And what we're gonna make our histogram on is the overall column. So let's do that. Let's first create our figure. And set the fig size to equals 5 by 5. Now let's create our axis. So I'll name it ax1 equals fig dot add underscore axes. And we put in 0 and 0 in the first two arguments because we only want one figure. And then we're going to use 1 and 1 because we want the fig size to be 5 by 5. Now let's plot our histogram. So use the histogram, and in between brackets, we put our overall column in the player's data frame. Now let's run that. The name of our data frame is players. Let's run that. And to remove these, I'll just add plt.show. And you see we created our histogram. We can add xticks to align with the bins. So we're gonna create our own bins here. But first let's create the xticks, plt.xticks. And we want it by 25. So I'm gonna do 0, 25, 50, 75, and 100. And then we need to use the bin arguments and use the same xticks values. So bins equals 0, 25, 50, 75, 100. And now let's run that. And you see we created our bins and aligned it. And you see we created our xticks and we aligned it with the bins. If we want a horizontal histogram, let's press Ctrl+C here, paste it here. And all we have to do is add the horizontal argument. No, not the, we use the orientation argument. And then we set that to horizontal. Let's run that. Oh, we have to put white ticks here. And let's run that. And you see it fixed the x-axis. We can also add an edge color argument. And we could set that to red. And you see we get a red outline over the histogram bars. So this is how you create histograms in Matplotlib. If you want to know how to add X and Y labels, you can refer to the previous video. Now let's move on to box plots in Matplotlib. And a box plot is a data distribution that is represented by boxes and whiskers. It takes a numerical array or arrays, and from that array it displays the mean along with the first quartile and the third quartile, and the whiskers extend up to 1.5 times the upper quartile and lower quartile. So here I imported the necessary libraries and I put our CSV file into a data frame. And we're only going to do the overall column. So before we create our box plot, let's create the figure. I'm going to set fig to plt.figure. I'm going to set the fig size to 5 by 5. And then we're going to create our axis and set that equal to fig.add axis. And we're going to put 0 and 0 for the first two arguments since we're only dealing with one figure. And we're going to set the last two to 1 because we want the fig size to be 5 by 5. And then let's create our box plot. Box plot. And we want the overall column in the player's data frame. Let's put plt.show because we only want the box plot. Oh, we need to put an equal sign. Let's run that. And you see we got our box plot. And we see this line represents the mean. This one represents the upper quartile. And the whiskers is 1.5 times the upper quartile. This is the lower quartile, and the whiskers, that's 1.5 times the lower quartile. And these little round things is the outliers. If we want to remove it, we set the show flyers argument to false. And let's run that. And you see the outliers was removed. And by default, it will be numbered. But if we want to put our own label, we just set the label argument to equals overall score. And let's run that. Oh, it's labels with an S. And you see we labeled our box plot. We can put 2 box plots on one figure, but first let's do some preparation for that. So I only want the inter players, and to get them, we call the players Dataframe. There's a column in our data frame called club name, and we're gonna set that equals to inter, and then we want the overall. Let me copy this, and for here we want Dortmund, and we set that to, in the club name column it's named Now let's create another variable and set that equals to inter and Dortmund. Let's run that. Oh, this doesn't need a equals. Let's run this cell. And it's the player's data frame, not player. We keep getting mistakes. Club name. Oh, the club, it has an underscore. The name of the column, club name, is club underscore name. And now everything is fine. So let's create a box plot comparing the 2 different teams. I'm just gonna copy this here. And then I'm gonna set ax.boxplot, and in between the bracket, I'm gonna put data. Then I'm gonna write plt.show. Let's run that. And you see we fit both of our box plots inside of the figure. If we want to change the default 1 and 2, we can set the labels to label equals Inter Milan. Let's run that. Let's see what's the problem. Oh, it's labels. Let's run that. And you see we changed the default labels. Now let's quickly just move into Violin plots. And let's create our Violin plots. We're gonna use the same figure and axis. And then we're gonna put the ax dot calling our Violin plot keyword. And let's put the data that we created up here. Let me add plt.show. Run that. And you see we created our Violin plots. If we want to add our box plot in the same axis with the Violin plot, we just call our this line right here. Control C. Put it here. And let's run that. And you see we put our box plot and Violin plots in the same axis. So now let's move on to Seaborn. And Seaborn is another data visualization library in Python. So here in this cell, I imported Pandas as PD, Matplotlib as PLT, and the reason why I imported Matplotlib because it works hand in hand with Seaborn, and I want to use it to create some labels, axes, and so on. And here I imported Seaborn as SNS, and I stored our CSV into a data frame. So let's run that cell, and you see we get our data frame. So first let's create a bar plot. So to do that, we put sns.barplot, and then we, in brackets, we set our x to equals, we want our region column, and set the y to equals our population column. And let's run that. And you see we created our bar plot. If we want to remove this confidence interval or error bars, we set the error bar argument to none. Now let's run that. It's error bars with a no S. Let's run that. And remember in Matplotlib, to remove this, we had to put plt.show. But with Seaborn, we could just add a semicolon and run this. And you see it was removed. If we want to change this to a horizontal plot, we simply change the X and the Y. So instead of X here, we put Y. Instead of Y here, we put X. And you change that to a horizontal. Let me put it back because I don't like it. And we can change the estimator to sum since it brings the mean by default. So to do that, estimator equals sum. Let's run that. And it brings up the sum of all the regions. We can use the hue argument for color coding and it brings up a legend. So let's set hue equals to, and we're gonna set it to region. Let's run that. Oh, I forgot our data frame. Let me just put this in here and run that. And you see we got our hue. But what that does is that it shifted our bars. To prevent this from happening, we can use the dodge argument and set that to false. And let's run that. And you see we got it back how we wanted it. Now let's move on to count plots. And the count plot is basically like a bar plot except for the aggregation. It just counts each observation and we just need to pass in an X or Y value. So let's create a count plot, sns.countPlot, and in bracket, we just pass the X value, region. And let's run that. Let me add this here to remove. And you see we got a count plot. And the reason why we imported Matplotlib, so if we want to edit labels and titles. So I'm not going to explain this because I explained it in Matplotlib in the previous videos. So let's set the fig to equals plt.figure to set the fig size to 10 by 4. Set the axis equal fig.add. Now let's set the labels for X and Y. So x.set underscore X label, and we want to call it subregion. X.set underscore Y label, and I want to call it count. Let's set the title. I'm just going to call it count region. Then I'm going to cut this, paste it here, and set the axis equals to the ax variable that we created. And let's run that. Now it's one title and T. And you see we created our labels, titles, and we resized our count plot. We can change the size to title by just adding the size argument and set that equals to, let's say 15. Let me put 20 so we can see the difference. And you see we got that bigger. And then we could do the same for the X and Y labels. Whoops. Let's run that. And you see we resized the X and Y labels. Now let's move on to box plots. And before we do that, we're gonna load another data frame. I'm gonna call it players data frame. It goes to pd.read_csv. The name of our CSV file is players.csv. And then remember this CSV file, it has a lot of columns, and by default, Pandas doesn't show all the columns. So we have to set the pd.set option. And we want to display .max underscore columns. And then the next argument we set is false. And now let's look at our data frame. Oh, here it's PD, not PF. And you see all the columns is displayed. And what we want is the overall column, the same column as the previous videos. Just know that there's an overall column here somewhere. I found it in the previous video, but it's here. So to shorten this video, I'm just gonna continue. So let's make a box plot of the overall score. So sns.boxplot, set our X to our PDF data frame, and we want the overall column. And let's run that. Let's add this here. And you see we got a box plot of our overall column. We can switch the vertical display. We just need to put Y here instead of X. And you see that changed the vertical display. If we want to remove the outliers, we set the flyers argument or flyer size argument, and we set that to 0. Let's run, and you see it, we remove the outliers. If we want to create a 2D box plot, we can set a X and Y argument. So let me just put this here. And then I'm gonna set Y equals to PDF. And I'm gonna choose the league name column. And let's run that. Oh, we need to put a comma here. Let's run that. Let me switch our X and Y. Instead of this league name column, let me just find another column so this looks better. I'm gonna put a real name. Let's run that. Oh, the name of the column is real face, not real name. And here you have our 2D box plot in Seaborn. If we wanted to rotate the axis, we put plt.xticks, and in bracket, we use the rotation equals 45. And let's run that. And you see our x-axis, it was rotated. So this is categorical plots in Seaborn. So now let's move on to relational plots in Seaborn. And before we create a line plot, I've imported the necessary libraries, and we stored our Excel file into a data frame. If this doesn't work, you might need to pip install OpenPyXL. And here's our data frame. It's about stocks. And here we created a year column, and we extracted the year out of the datetime column to create a year column. So now let's create a line plot in Seaborn. So sns.line plot. We want to set the x to equals the date and the y to equals the closing amount. And then we need to set the data as our data frame. And let's set the hue to the symbol. I think there's 3 symbols: Facebook, whatever this is, and something else. So now let's run this cell. And you see we have our line plot with our different symbols: Facebook, Microsoft, and so on. If we want to remove this, we just put a semicolon here and it's removed. We can also change the figure size with PLT figure, Matplotlib figure. So let's set the fig size to 10:6 and let's run that. And you see we resized our line plot. We could also change the way how it's displayed, and we could change this with the line style. And there's dotted. Let's run that. And you see the line style is dotted, and there's also dashed. It's dashed with a ED. We can add our own colors, but the amount of colors need to correspond with the amount of symbols. So we do this with the palette argument. And we set that equals to, let's do red, black, and blue. Let's run that. And we change the colors of our line plot. So now let's move on to Rel Plot. And a Rel Plot allows us to draw relation plots such as a line plot and scatter plots on a facet grid. And a facet grid is just a matrix of plot. So let's create SNS.Rel Plot. Set the X to date again. Set the Y to the close column. Data equals data frame. Hue equals symbol. And then we use the kind argument, and here we put line, so we can make a line plot. Oh, the symbol column is with a capital S. And you see we did the same thing. And another thing about the Rel Plot is that it takes the height and aspect argument, where height is the height and the aspect is the width. If we say the aspect is 0.5, then that means that the width will be 0.5 times the height. So now let's add height equals 3 and the aspect equals 2. So it will be 2 times 3. And let's run that. And you see we resized our line plot. So now let's add the row argument, and this is gonna change it to a facet grid. And we set the row to symbol. And this is gonna give us line plots under each other. Let's run that. And you see we have each of our symbols on separate line charts. If we want it to be columns, we use the column argument. And let's run that. And now it's across. And now it's 3 line charts, one after the other. Let me change this to 1. This is a little better. So now let's move on to scatter plots. And before we do that, let's load a sample data set that SNS has. So I'm gonna set P equals to SNS.load underscore data set. And the name of the Seaborn data set is penguins. Let's look at that data set. And here you see we loaded it. So now let's create a scatter plot in Seaborn. So SNS.scatterplot, and we're gonna set X to equals to body mass in grams, and Y to equals build length, and then we need to set the data to equals p, which is the variable where we start the data set in. So let's run that. And what's the problem now? I spelled length wrong. Let's run. And you see we got our scatter plot. We can add the u, and we'll set the u to the sex column. So u equals HUE equals sex, and let's run that. And you see we got the male and female scattered on our plot. Now let's use Rel Plot along with the facet grid. So I'm gonna write sns.Rel Plot, and it's gonna be the same x equals y and the data. And we want to set the column to, let's set island, because I think there's 3 or 4 different species. So the island column, and we have to specify the kind and set that equals to scatter. And let's run that. And you see we made a Rel Plot or a facet grid. The column is the island, so for every island is gonna set its own scatter plot. We can also set row, and it will be one under each other. There you have it. Let me just put column because it looks better. So now let's move on to pair plots. And when we create a pair plot, we have to make sure that the data frame does not have too many numerical columns, because 4 numerical columns result in 16 plots, 8 results in 64, and so on. And it brings a scatter plot by default. So let's type sns.pairPlot, and we put our variable p. Let's run that. And you see it created plots for all the categorical variables in the data frame. We can also add a u. So we set u to equals, let's see, let's do species. And let's run that. And you see we splitted all the plots based on the species. Let me quickly show how to make a histogram. Seaborn is called hisplot. Let's run that. So we do sns.hisplot. Then we set the x to equals body mass, and the data equals p. And let's run that. Oh, we forgot to add an end quote and remove this one. So let's run that. And you see we made a histogram. And histograms can also take a u. So let's set u to equals sex and run that. And you see we create a histogram for the males and the females. So now let's move on to regression plots. And to create a regression plots, we first need to find the correlations between 2 categorical variables. And to do that, we just type COR, R, and we run that. And we could see how strong each column is correlated. And you see body mass and flipper length has the highest correlation. So let's make a regression plot based on the body mass and the flipper length. So sns.regplot, we set x to equals the flipper length. Let me just copy it so I don't spell it wrong. And the body mass. then we need to specify which data frame is it. P. Let me add a semicolon and run that. And you see we drew a regression line, or the best fitting line inside of our scatter plot. And I'm not sure if you can see, but there's a confidence interval, like a light blue coming out of the line. And if we don't want that, we can set the CI to none. And it was removed. So now let's move on to implots, and with implots we can plot a red plot on a facet grid. So let's go ahead and do that. SNS.implot, and I'm just gonna copy this, Control C, and then I'm gonna add a height to equals 5, and then an aspect equals 1.5. So the width will be 1.5 times the height. Then I want to set the row to island and the column to sex. Let's add a semicolon and run this cell. It's not implots, we need to add a L, and let's run that. So it's LM plots, not IM plots. And here you see we created a facet grid of regressional plots based on the categorical values in our data frame.